Well, welcome back to the Azure Podcast. This is episode number 411, being recorded on the 9th of February, 2022, with special guests Suhas Rao and Graeme Foster. I'm Sujit, and on Teams with me, we have Cynthia and, of course, our special guest, who we're going to get to in just a minute. But before that, let's take a little bit of a look at the news in the Azure space from the past week. Cynthia, I believe you have a couple of items to cover, and I'll go after you.
Sounds good. And I do have to say credits to Evan. I did not find these. But updates according to Evan. First one is public preview for anomaly detector. So right now, you're able to synchronously do multivariate detection, as well as some improvements on the anomaly interpretation. And I believe the experience before is that you would have to upload your data to a blob storage for inference, but now you're able to just do it directly in the API request body. Pretty cool. And then the GA of there's some deployment enhancements for SQL Server on Azure VMs. Until now, it has usually come pre-built with default configurations, which requires you to continue to configure the image depending on what exactly you want your SQL Server to be. And now you're able to set it up more in an earlier part of the process instead of after the deployment. So definitely take a look at that. And then the last one, also in public preview, is that Bastion now supports file transfer via the native client. So you can either use SSH or RDP to upload files to a VM from your local computer. And you're also able to download files from a VM to your local computer via RDP.
Yeah, that last one, Cynthia, is pretty interesting because now you could just use the AZCLI command for the Azure Bastion service and set up a tunnel, like a virtual tunnel between your laptop and the target server going through Azure Bastion. And once you've set up the tunnel, then you can use just the normal tools like SCP or SSH, right? The ones that we're normally used to using. They'll just work through the tunnels. I think that was a nice feature that they added on. Otherwise, you had to use the browser or the portal experience to connect in, which is good, but it's not as good as the native experience.
An extra window.
An extra window, yeah, exactly. Well, so I had a couple of ones. The first was in the Azure Cache space, Azure Cache. As you know, that's our Redis cache service where for a geo redundancy, they allowed you to have two replicas or two instances of the cache that could in different regions that could replicate to each other. Now they've expanded that you can have up to five regions connecting to each other. And what this means is that your SLAs are now 5 nines, which is just amazing, right? Literally never going to go down at that level. So, that that level of replication is available now in Azure Cache, Redis Cache. The other one is in the AKS space, and I'm covering for Kendall over here when I say this, but so AKS, as you know, you could you have pods and things like stateful sets and replica sets and all these other kind of workloads that you can run over there. And typically they don't require any storage, but there are some kind of workloads like the stateful applications, like stateful sets, that do require persistent storage. And so you mount persistent volumes in AKS to support that. And now Azure Backup, right, has a facility where they can back up those volumes because those volumes contain valuable data, obviously. And in case you have a complete meltdown of the cluster and you have to recreate it, you can now rehydrate that. Or if you have a dev test scenario where you have different regions and you want to replicate that persistent volume across various clusters, you could use the Azure Backup to do that little backup and restore. So that's another feature that's currently in private preview. So check the website if you want to sign up for that. So I think that's a good roundup on the news. Well, I'm excited to hear from our special guests today. Both of them are from Australia, so really glad that they could join us today. Suhas, I'll start with you. Please introduce yourself, and Graeme, you can follow.
Sure. Thanks so much, Sujit. I started my journey in Microsoft about 12 years ago as a dev, wore many hats, was a consultant on the field, have been an architect for last 3 years, working with our large FSI customers here in Australia. So event-driven architecture, which is one of the topic, is something that I kind of love and have been working with our customers. With that, I will hand it over to Graeme.
Thanks, Suhas. Yeah, so hey everyone, I'm Graeme. I'm based over in Perth in Western Australia, so the sunny part of Australia. And I've been working at Microsoft now for just over a year and a bit, I would say. But like 25 years in IT, so I cut my teeth on my ZX81 way back in the day, and just got a passion for it. Absolutely love working in this industry. And over the last sort of 10, look at that, it's got, wow, love your work. So over the last sort of 10 years or so, I've had a really big interest in messaging systems, worked for some interesting retail businesses and financial organizations where we've really had to embrace kind of microservices and event-driven architectures. So super excited to be here today and to talk a little bit about it.
That's great. Yeah. I mean, I think it's become a recent buzzword, actually, event-driven architectures. I've been hearing more and more about it, both inside Microsoft and with our customers. The common question I get from most people when I mention it is, what exactly is an event-driven architecture? It has some connotations when you hear the word event, but I think it means more than just that. So, Graeme, I was wondering if you could quickly give us the elevator pitch on an event-driven architecture.
Absolutely cool. Well, look, I mean, I think you've got to go back a long way and have a look at what we used to have when we were building systems to run your business. We'd have these huge monoliths, right? And it got very difficult to work on them, very difficult to maintain them. And about 15, maybe, I don't know, 15 years ago, we embraced this idea of service-oriented architecture, where we took these big things and we started to turn them into smaller things, which were more centered around business capabilities. Service-oriented architectures gave way to microservices, which are really, really commonplace nowadays. But we still see a lot of issues with these architectures where these services tend to call each other directly and make all of these kind of, hopes that the services are up. So a simple question would be, if your service goes down, like, will that affect others? Are you going to create this cascading change of failure across all of your environment, right? A really bad place to be. Now, an event-driven architecture really is one where we try to remove lots of those point-to-point service calls. And instead, we drive communication between those services using these things called events. An event is really just a broadcast of something that's happened in your world that others might be interested in. Right, so let's think of a real-world example. Think of a shop, right? What happens when someone buys something in your shop at the point-of-sale system? Well, maybe in your organization, inventory might need to purchase some more stock from the wholesaler. Marketing, they might want to know that someone bought that item so they can cross-sell something. Maybe you've got an insurance arm, right? So they want to contact the customer to offer them an upsell. So we could have a world where that point-of-sale system calls each of those services one by one to tell them about the purchase. And we see a couple of common approaches to that. You might have this idea of what we call synchronous calls, where the services are connected, not just they know about each other, but they're temporally connected. So you make the transaction, you call all those services. But what happens if one's down there, right? So do you complete the point of sale system? Do you let the customer walk away with their goods? How do you notify the wholesaler if you do that? The other one is that the point of sale system starts to get this really, really deep knowledge about the business processes that need to hang on it. So if you want to introduce a new business process into your organization, you might now have to orchestrate changes across a whole bunch of different systems to make that happen. So you get this kind of backlog coupling between the teams that are building these things, which can be a really dangerous place to be in. So an event-driven architecture kind of flips this on its head, right? So think about that POS transaction. When it's complete, what about if we just broadcast some information to the world about it, but we don't care who's listening to that? And then all of these different services can listen to that event and react to it. So we invert the coupling, right? The POS system doesn't care about who is listening to that event. So why would you do this? Well, look, it reduces the burden of knowledge on that POS system, and it creates this environment where we can bring on new services and create new business processes without having to affect these existing systems. And it can also sidestep some issues that we see around tight coupling and scale that we can get with those point-to-point communications. So for me, that's kind of why we would choose to go down an event-driven architecture.
Graeme, kind of following up on what you were just talking about. So let's say there is a event that was broadcasted and one of the service is busy handling a previous event or two previous events that it got. How does it keep track and how does it ensure that these events are not lost? Or is it on the broadcaster's responsibility or is it on the subscriber's responsibility?
Yeah, right. So great question. So the first thing I would say is that the system publishing those events really can't have any knowledge about the subscribers, and there could be multiple of them. So we can't put that burden on the subscriber's side. So we have to make sure that on the publisher's side, we have to make sure the publisher can raise that event and not be concerned about others that can't handle it at that point in time. So we have a few different options that we can choose. And nowadays, we tend to see managed services, certainly in the cloud, like message buses or event grids or things like that, where we can literally push an event out to a service that will hold on to it and be able to deliver it for us on our behalf in the background to the service when the service is available to handle it. So it creates like buffers between the services, meaning we don't hit this situation of a subscribing service not being able to handle a message because of its load.
So this sounds obviously very, very exciting, right, from a customer perspective. But tell me, like, how do customers even start approaching something like this? How do they say, oh, I think this should be an event-driven architecture versus a non-event-driven architecture. And I'm sure it can't be easy to build these systems. So what are some of the challenges that our customers might face when approaching this architecture?
Sure. I can kind of talk on behalf of some of the customers that I have been working with, right? So like what you called out earlier, Sujit, there is this general interest and awareness that is increasing. So if you look at the forums, the tech communities, the user groups, there is many more conversations around event-driven architecture that's kind of making its rounds. In fact, it's quite interesting. The other day I kind of stumbled upon this paper that was written by Gartner in 2018, which basically said event-driven architecture is one of the top trends. In fact, these guys have a pretty accurate crystal ball, right? They went to go and say that by 2022. Event-driven architecture is going to be really big, so much so that about 60% of the new systems are going to have some form of event notification baked into it. So, so that's one thing, right? So there is this general awareness, which is definitely getting better. The second bit is also, right, like what Graeme kind of called out, we used to have this monolithic architectures. So as people are moving to the new microservices-based architecture, right, they're coming across these standard problems, right? So, hey, I have so many microservices. How do I let them interact without making them really tightly coupled? How do I scale them independently? How do I deploy them independently? How do I manage change, right? And that's when they'll start looking for patterns. And then they kind of stumble upon the event-driven architecture as one of the patterns. And quite honestly, event-driven architecture is a really, really good pattern, that can solve a lot of these problems. It's an elegant pattern. Cynthia?
Oh, I was gonna wait till you're done with your explanation, but while you're describing that from a customer journey perspective, is this like a bottoms up, I have to slash everything and start event driven? Or is it something that I can like start sectioning a part of my monolithic architecture and then modernize like that part first and then like peeling my monolithic architecture into smaller bits and modernize that way?
Yeah, like what Graeme and I like to kind of talk about it, right? So event-driven architecture, it's not a silver bullet. Graeme, do you want to add to that?
Yeah, look, I think event-driven architectures are something that you can definitely start to dabble in, right? So a good example I've actually got from my last job was we had a very big monolithic application. It's actually a mainframe application. And we had the need to start to enable microservices that were being built in a kind of more modern fashion to integrate with the mainframe. So one of the things that we actually did was we wrote a little program that you could execute from within mainframe kicks, it's all very old school kicks transactions, that could actually write to something that could then broadcast out stuff from the mainframe. Because we were never going to be able to break down that mainframe, certainly not in a kind of reasonable time frame. You had many years to actually split that thing apart. But it needed to come along with the rest of your architecture on the journey, like especially in the world of digital transformation, where you're trying to create these rich experiences and you need those legacy systems to be part of that. So enabling the ability to send events out can really help you unlock that value in those old systems without having to do that much work on them to get them into the new world.
Now, if I'm a customer and I'm looking at, okay, I've decided, okay, I want to implement something like an event-driven architecture, and I look at Azure, there seem to be a lot of confusing choices in terms of how to use Azure, to leverage Azure, because obviously I'm not going to roll all this on my own, right? We do need a lot of supporting services from the cloud, and Azure has a few of them, and there's many of them that have the word event in them, in fact. So give us a feeling for how customers should approach this. What are the options in Azure, and what are maybe some of the pros and cons of each of these options?
Cool. Do you want me to take that one, Sujit? I'll go with that one. All right, sweet. So yeah, look, I've got to admit, I've come from a world where you basically had two options. It was either RabbitMQ at some organizations, or it was Kafka at other organizations. So it can get a bit overwhelming when you get to Azure and you see all these services with event in the name. Now, luckily, we've actually got some great resources out there on our websites written by people like Clemens Vasters that can really help you walk through which of these services are there to do which things. But I'll focus on three main ones. Two have got event in the name, one hasn't. So I hope you're all right with that. I'll kind of like cheat the question a little bit. So we'll go with Event Hub, Event Grid, and Service Bus, because I think those are the three ones that are really aimed at communication between discrete services. So I'll start with Event Hub, right? Event Hub's a really interesting one. It's an ingestion service where we can send it massive amounts of data that we want to potentially analyze in different ways. So if you've got sensors in the field, you've got SCADA data, you've just got tons of telemetry that you want to get into Azure, then Event Hub is awesome for that. But when it comes to, let's say, a business application where you absolutely have to process messages and you need guarantees and you need poison queues and things like that, Event Hub doesn't really give you that. It lacks a lot of those high-level application features. So if you're trying to send a financial transaction to withdraw some account from money from a account, well, it doesn't provide you, let's say, deduplication. It doesn't deal with poison messages. It doesn't give you transactions across sending and receiving. It doesn't give you competing consumers to really be able to scale out at the times when you have high load on your system. But it's brilliant for feeding data in something like Spark, where you can analyze it. So the main, I think, criteria we sort of point people to is that if your individual events don't really have value in themselves, so this might be the temperature of a sensor, where it makes more sense to analyze it over time to get the interesting results, then Event Hub is the service for you. So let's move to Event Grid. Still got event in the name, so I think we're tracking well there. Event Grid's a brilliant service for broadcasting what we call discrete events. So these are different to the telemetry events because a discrete event has kind of meaning in itself, right? It actually makes sense to process it as a message on itself, and maybe some action comes on the back of that. Now, in many ways, we used to use topics in Service Bus instead of Event Grid. But Event Grid's really interesting because it's cloud native at heart. So if you think of Event Hub and you think of Service Bus, the way we pull messages from them is that we pull them. I said it in the word, it was kind of implicit there. So we have to have a process running that can reach out to those services and say, hey, give me the messages. Now, that might mean that you have to run a VM or a container all the time. We have the functions host that can actually do that for you, but it's still pinging that background service. So if that's charging you per transaction and you have thousands of subscribers, then that might start to make a material impact. The event grid is reactive in nature. It's very different. So you don't call it, it calls you when something arrives. But the scale can be a bit daunting. So event grid can massively scale. If you get 1 billion events arrive at it in a very short space of time, it's going to notify you as fast as it can. And that can overwhelm subscribers if you're not careful. So it can be quite useful to actually start to combine these services together. So you might use event grid as a way to actually allow publishers to publish their data, but you can connect event grid, say, to a service bus queue. And that would allow a subscriber to not be pummeled by event grid, but to actually slowly work its way through those messages in a rate that it can handle. So that nicely takes us onto the service bus, which is really like an old school message bus, right? It supports classic protocols like AQMP, meaning that it's got reach into many different languages and frameworks. Send the message to it and it delivers it. It can deduplicate messages for you. It can guarantee the ordering of those messages by using sessions. It can wrap, receive, and send operations into transactions. So you either succeed or fail processing the message and sending new ones as a whole. It can route messages based off like a little simple SQL language that you can plug into service bus. It supports poison messages. So if you fail to handle messages multiple times, it will back off and retry them and eventually put them into a new queue. So this is all really, really useful stuff when you're writing business applications that need a lot of these guarantees when they're processing messages. So I think, 3 different services, each has got its own sweet spot, and it might not necessarily be that one is the right one for you, but it might be a combination of them.
Cool. Just to kind of add to Graeme's points, right? So yeah, I mean, so we as Microsoft, we have a history of poorly naming some of our services. I mean, that's again, from an event broker perspective, right? So I think Graeme did a pretty good, coverage of all of them. Now, again, moving outside the event broker, when we are talking about orchestrators, right? So we have, durable functions that can do a bunch of orchestration for us. Then we have logic apps that also can do orchestration. Then there is Microsoft Flow. I think we have renamed it recently. It's called Power Automate now. So yeah, we do have a whole bunch of services, and this is where customers find it challenging, right? So as they are kind of going on their whiteboards, they're like, hey, which service do we use? Now, that's the first challenge. Now, as you kind of move on, right? So let's assume that you have got the design in place. The next is about, okay, how am I going to define my event schema? How light am I going to keep my event schema, or how heavy am I going to make it? Right. So there is, again, some guidance in form of the event grid schema that we provide. There is also a cloud events, if you're kind of building these massively distributed multi-cloud applications. So you can look at, cloud event schema. So that's the second challenging bit, right? Because I have ended up in a lot of endless meetings where people keep debating, how to structure their events. The next bit is around the visibility, right? So, and this is one of the shortcomings of the event-driven architecture, because once you emit an event, right, as a publisher, you don't have any idea as to where that event would go. What are the subscribers that are listening to those events, and how are they going to react to it? So there is no statement of overall system behavior. And that's where something like our application insight, it's got a capability called as correlated distributed telemetry. So it can basically help you get that end-to-end view, provided you have structured around correlation. So then that's the other challenging bit on getting that visibility. The next bit is around error handling and fault handling. That's a very important topic when it comes to building those event-driven architectures. Then other bit which Graeme already covered is the scalability issues, right? So if you use something like Event Grid, then you have a bunch of subscribers. Now you need to let them scale as well, and this can be especially hard, right? Because a lot of times we see that there are older systems out there like maybe insurance quoting systems that have to be on premises. They don't scale well. And like what Graeme said, right? So you kind of use a pattern of event grid that goes to a service bus, and that basically throttles those requests there. So yeah, these are some of the challenges that I see working with customers day to day.
Yeah, Cynthia, you had a question? Go ahead.
You go first.
Okay. Yeah. So I've done some work with message-oriented architectures, right? And I believe this falls into that category of message-oriented architectures. There are some fundamental concepts in MOAs. For example, things like commands, events, and handlers. So things like that. So it maybe just helps to ground our listeners on what those concepts are. Some things that we have to think about, right, when we move to these kind of systems, because that's how the programs are going to talk to each other when they deal with EDS.
I'll take that question. So I'd like to kind of start off with a one sentence, a definition, right? So basically events, then we also have something called as commands. They are types of messages. Now, if we look at events and commands, right, they look very similar. They move around in a very similar fashion. They go from one place to another place via buses, topics, queues, right? So, but what differs between them is the intent. Probably what I'll do is I'll take an example, right? So we are recording this podcast. We are going to upload it somewhere. Then there are going to be a lot of nice people who are listening to this. They will probably react by giving their feedback, right? So basically at this point of time, I don't have any expectation that someone's going to react to it, someone's going to give a feedback, right? So that is an event, right? So I'm basically emitting an event with no expectations. Now, instead, I might go and say, right, dear audience, can you please go and smash that like button if you like this podcast, right? So that is a command. So then again, right? So that's an event and a command. But then there are two types of messages. There are also other types of messages like query. So query is something that is special, right? So query is when a system sends out a message requesting more data, right? It wants to obtain more information, so it sends out the query. So what is special about a query is that it needs to include the sender address. Then what you have for a query is the reply. So now the sender address, you're going to reply back with the data. So these are, again, different types of messages: events, commands, queries, and replies.
Cynthia.
I was like, I'm trying to find the unmute button. But I have two questions. One following Suhas's earlier comments around messages and events and commands. When a subscriber gets an event, does that event contain any sort of data, or is that the event purely that X has happened and you wanted to know things that happened to X, so now go do something about it? Or does it contain the information around like X has happened and these are all the associated data, and then you can start working with it? First question. And then the second question is, in terms of the different services that, Graeme, you were mentioning earlier with Service Bus, Event Hub, and Event Grid, and those integrating with some of the more, older systems, what are some of the restrictions of what can or cannot be used, or is everything just easily integratable and works like a charm?
If Graeme would let me, I'll take the first question and I'll let Graeme take the second question. So the first question, right, again, it goes back to what I was talking earlier, right? I have been in endless meetings where people have debated day in, day out regarding how lightweight or how heavy the event should be. And again, there is no right answer, right? In this world, it all depends. So just as an example, right, I'll kind of take an example of an insurance system. The insurance system is where customers go, request for an insurance, right? And in this insurance system, let's say the customers move from one place to another place. So at that point of time, they go and update their address. Now, let's the business rule basically says that if the customer has relocated from one address to another address, go and do a recode, right? So the first thing is, if we kind of look at it, right, the insurance system basically has two components. One is the customer management system, which is emitting an event telling the address has changed. Now, going back to your point, Cynthia, right? So if I were to just emit, okay, my address has changed. Now let's take a look at that insurance quoting system, right? So now it has to react to that address change. So all the information that it has got is that the address has changed. Now, is that adequate for me to go and do a recode? At this point of time, it's not, right? So now what I need to do, I need to go back to my customer management system and then request this additional information, right? So that is one way of kind of approaching it. We can have a query, then we get a reply. Yes, you can do that. But there is also another pattern, right? Wherein I, as the insurance quoting system, I'm going to maintain the state myself. And the message that or the event that the customer management system sent is going to contain all the state information that the receiver would need in order to not go back to the original producer, right? So that is actually a pattern that people use. That's called as an event carried state transfer pattern. So those are basically some ways in which you can go and define how lightweight or how heavy you want to make your event. With that, I will let Graeme answer the second question.
I know this feels like a really good interview question as well. There are so many different connotations of things that can connect to things, and I know I'm going to get one of them wrong on here. In the comments, someone's going to hit that dislike button. But look, ultimately, there is very good connectivity between these services to other subsets of services, but you can't connect everything directly to everything. So you might sometimes need like a process in the middle that can handle input from one and send input to another. But generally, like, our services like logic apps and functions, our serverless services are really good at having bindings to our messaging platforms, our eventing platforms. So a logic app, a function, they can all be triggered from event hubs, event grid, and service bus, and they can all send messages back out the other way. Now, some of those services like Event Grid have got first-class support for actually connecting into the other services. Now, the specifics, I'm not sure exactly which is the superset of services that they will do that to, but for example, an Event Grid can directly within our portal connect to a service bus to send forward messages onto the bus. An Event Hub, for example, can be connected to a Stream Insights service to allow Event Hub to flow directly into that as well. So I think the answer is, I don't know off the top of my head exactly which can connect to which, but there's a fairly good amount of connectivity. Most of them all connecting to our serverless platforms to allow you to trigger your business logic. And yeah, we have some very good documentation on the old internets for that as well.
So I know we kind of covered a lot of ground here, but I want to, I've heard also, I've heard with worked with customers that have said the Saga pattern, right, is a better pattern to use in some cases. Can you contrast that versus an event-driven architecture pattern?
Sure. I'll try taking that question, and Graeme, feel free to jump in.
And just maybe for our listeners, just give them a quick overview of what a Saga pattern is. We kind of try not to just blurt out too many acronyms over here without and confuse.
Absolutely, 100%. So what Saga pattern tries to advise us is on building distributed systems where we have multiple local smaller transactions, right? So it kind of gives us a design pattern that we can follow when we are implementing that. Again, I'll just to kind of make it easier for the audience, right? I'll take an example, right? So let's say a business transaction is around going and booking a holiday, right? So if we look at that, so there are three different activities that should happen. One, I need to go and book my car. Two, I need to go and book my hotel. Three, I need to go and book my flight. Now, these are three different independent systems, right? So what basically Saga Pattern says is that you go with your first local transaction. Once it's complete, it emits an event telling it's complete. That triggers the next one. So my car rental is done. then I go and book my hotel, and then I go and book my flight. But the important thing to remember, what Saga Pattern says is that if there is something that fails in between, we need to have a compensating a transaction that happens. So if, let's say, in the last step, right, I have booked my hotel, I have booked my car rental, the flight booking fails, the system should be able to have those compensating transactions so that it can roll back and leaves the system in a consistent state. So that's how the Saga pattern works. Graeme, you want to add to it?
Yeah, definitely. So it's a really interesting one, actually. I remember many years ago when I started looking at event-driven architectures, and I couldn't get my head around what Saga meant, because if in the .NET space, a lot of you might have heard of a product called End Service Bus. And End Service Bus talk about sagas a lot. But their version of what they call a saga is quite different to if you read some posts by Kelly Summers or Clemens Fasters. And what I kind of worked out is that a saga is really, and again, like this could get a lot of dislikes, is a kind of catch-all term for being able to compensate a transaction that runs over many disparate services. So it's this idea of now we don't have two-phase commit and distributed transactions, and we're actually asking all these remote services that have got their own transaction boundaries to do things, how do we handle failure? So that's kind of the real essence of what a saga is. And then you can layer different actual workflow patterns into that as well. So you'll come across terms like a process manager or a routing slip, right? These are all patterns for managing workflow across lots of remote services. And the idea of the saga is that these services are all operating independently. So how do we compensate for things that go wrong? There's a really good paper, actually, I recommend reading. It's a very old one. It's called Starbucks Doesn't Do Two-Phase Commit. And it's an introduction into this idea of actually correlating a workflow across multiple people, as it happens in Starbucks, to get a cup of coffee out, and what can go wrong and how the whole system compensates for it along the way. And it's a really good introduction to like microservices and sagas and rolling back patterns across remote services.
Yeah, that's a really great response. Thanks to both of you for that. Yeah, I mean, when I think about it, right, the cloud there are going to be failures, right? You have to design for failure. That's one thing I tell all my customers. If you're expecting things to work in the cloud, thinking that it's better than what you have on premises, that is not the right approach, right? The cloud is going to fail. It's just a matter of when. And so you have to build. And so obviously, something like the Saga pattern does help. But when should one use more of in an event-driven architecture where there's commands, the fire and forget kind of style of commands, right? Versus something where you're doing very meaningful you're kind of checking the state of completion and doing compensation and things like that. Are they competing things, or do you see them go together?
I can handle that one if you want. So I think that these are all tools in your toolbox at the end of the day, right? So whenever you approach a business problem, you're not going to find there's a black and white answer to what you're trying to do. So even within a single organization, each of these patterns might make sense in certain scenarios. Now, if you have these sort of complicated workflows where you're trying to orchestrate a business process across multiple systems, then it might make sense to have a central coordinator where you can get really fine-grained and you can handle failures. Maybe you need to be able to report over the status of a long-running process as well. So having that centralized like a process manager where you can literally go to this process manager and say, what is the current state of all the workflows that are in operation? Right? You might need to version them. How do you version a process if it's broken up such that you're getting this emergent behavior appearing where you can't actually point at what's orchestrating that? So if you're in that scenario where maybe you're regulated, maybe you need to know where your workflows are, maybe you need to version in process workflows, then these process manager approaches where you might be using more commands rather than events and telling services to do things can make more sense. I think when you're really decoupled, so you have a business process that ends, and then the ones that start off the back of that are almost incidental, then that's when pure eventing can really help you, because it's a very simple way to kick off those processes without having to put too much work into building like new workflows and new orchestrations. So I think, you know, there's many ways you can do this, but knowing those patterns and being able to apply them to the context you've got is the really key thing. So, and it's a terrible consultant's answer, right? It depends.
And just to again add to that, right? So Sujit, you know, going back to your point around, you know, transient failures, right? So that's something that we can expect with pretty much any distributed cloud application today. The good news is a lot of our services, right? So they have the patterns and, you know, implementation to kind of overcome that. So for example, right? So Event Grid provides us with a durable delivery. You know, it has a retry mechanism built into it. So does a lot of our client SDKs, right? So does Event Bus. You have retry schedules, retry policies. So you kind of start off from there. You use out-of-box capabilities as much as possible. But then with retry also comes, you know, because what retry means is that we are having an at least once delivery. Then what you need to do is you need to have idempotency in your process that's handling it, right? So those are, again, you know, some of the things that you need to start including as part of your overall design.
Sounds great. That's yeah. I think that's a lot of food for thought for our listeners, I'm sure. I thank you for all of that. Cynthia, any last thoughts for Graeme and Suhas?
No, has it just been a great opportunity to learn about all these different architectures and patterns.
Thank you. Thank you very much.
Thank you so
and
much,
if you have any resources, I know Graeme, you mentioned a few in passing. Feel free to send them over to us, and we'll add them to the show notes along with the podcast.
Beautiful. Yes,
Thanks.
I've got a big list of resources, so we'll get them over for the listeners.
Thank you.
Absolutely. Thanks for the opportunity, folks. Nice talking to you. Bye.
Yeah.